You know, we use numbers all the time, right? But have you ever really stopped to think about them? Like, that they have their own little families? Maybe even personalities? Well, today, we're going to take a quick tour of this whole universe of numbers and get to know the basic building blocks of, well, all of math.
So let's just dive right in with a big question. Are all numbers created equal? I mean, is a plain old 2 the same kind of thing as, say, a super famous number like pi? The answer, and you might be surprised here, is a big nope.
Okay, so our first stop on this tour, we've got to start with the foundation, right? The numbers we all learned as kids. We're talking about whole numbers.
So what is a whole number? Well, it's pretty much exactly what it sounds like. It's a complete, solid number. No fractions, no decimals hanging off the end. These are your basic counting numbers. 0, 1, 2, 3, and on and on. The rule of thumb is super simple. If you see anything other than a 0 after the decimal point, you're not looking at a whole number.
And listen, the range here is just incredible. We're not just talking about the small numbers we use every day. A whole number can be as simple as 0, or it can be this absolutely mind-bogglingly huge number. What is that, over 8 quadrillion? Wow. But the rule still stands. As long as it isn't broken into pieces, it counts as a whole number.
All right, so we've got our feet on the solid ground of whole numbers, but what about all that empty space between them? You know, what's hiding in the gap between, say, the number 1 and the number 2? Well, let's dive in and find out.
And this is where we get to a really key idea. Think about it like this. Decimals and fractions. They're just two different languages for saying the exact same thing. Both of them are ways to talk about a piece of a whole. Let's actually see how this plays out. Take a look. You see 0.4? That's just a different way of writing 4/10, or 4 over 10. And notice what happens as we add more zeros after that decimal point. The bottom number of the fraction, the denominator, it just gets bigger by a factor of 10 each time. It's the same value. It's just dressed up in different clothes. So 0.004 is, you guessed it, just 4 thousandths.
Okay, so we've got whole numbers, and now we have these pieces in between. Well, it turns out they all belong to one big, happy family. And this family has one very specific rule for who gets to join. It's time to meet the rational family. So what's the one and only rule to get into this rational club? It's actually really simple. A number has to be able to be written as a fraction, a ratio of 2 whole numbers. If you can write it as something over something else, boom, it's rational.
And check out just how inclusive this family is. A whole number like 25? Yep, that's rational, because you can just write it as 25 over 1. A classic fraction like 4/5? Well, duh, that's in. What about a decimal like 0.75? That's just 3/4 in disguise. And even good old 0 makes the cut, since you can write it as 0 over 8, or, well, 0 over pretty much anything. But here's the twist. Not every number plays by these rules. Not everything can be written as a nice, neat, tidy fraction. Some numbers are the rebels of the universe. They just break the rules. So let's go meet these mysterious, never-ending numbers. And this is where we see the great divide in the world of numbers. On one side, you have the rational numbers we've been talking about. Their decimals are predictable. They either stop, like 0.5, or they fall into a nice repeating pattern. But on the other side, you've got the irrationals. And these guys can never be written as a simple fraction. Their decimals just go on and on and on forever, with absolutely no pattern to be found. And of course, here's the biggest rock star of the irrational numbers, pi. We all use shortcuts like 3.14, but its real decimal form just keeps going forever, with no pattern. You could calculate 1 billion digits of pi and you would never find a part that repeats. It just can't be wrangled into a simple fraction.
Another really famous member of this irrational club is the square root of 2. That's the number that when you multiply it by itself gives you exactly 2. And just like its friend pi, its decimal representation is this wild, endless, totally non-repeating string of digits.
And this right here really gets to the heart of it. This is the one thing that defines them. It's not that they're complicated. It's that they are fundamentally, unfractionable. That is the essence of an irrational number.
All right, so we've met the families, right? We've got the whole numbers, the rationals, and those mysterious irrationals. So let's see if we can put this all together now and actually start mapping this crazy universe.
Okay, pop quiz time. How would you classify these? First up, 35.0. See that .0 on the end? That's your clue.
It's just a whole number in disguise. Next, 6/12. Well, it's already written as a fraction, so that's a dead giveaway, right? It's rational. And last but not least, the square root of 2. Come on, we just met this guy. A classic irrational number.
And just when you think we've got it all mapped out, we hit the very edge of the known universe. So what happens when you try to break the ultimate rule of fractions? What happens when you divide by 0, like 9/0? Well, you start to touch on the concept of infinity. Now, infinity isn't really a number like the others we've met. It's more of an idea, a concept, for something that has no limit, no boundary at all.
So when you step back, you see it. The numbers we use every day are part of this huge, structured, and sometimes wonderfully weird universe. We've gone from the solid ground of whole numbers to the endless chaos of the irrationals, all the way to the mind-bending idea of infinity. Each family has its own rules, its own place. And it really makes you wonder, doesn't it? What other beautiful, hidden patterns are just waiting for us to find them, right beneath the surface of the math we think we know?